Okay, we are going to continue looking at circles. And this example on the left is very similar to what we have, or what we discussed yesterday. We have graphing form here, x minus h squared plus y minus k squared equals the radius squared. Over here, though, this looks a little bit different. It looks very close, but we have now a number in front. But I see we have a number in front of both of these, so I'm going to divide all sides of this equation by 2. So I'm going to divide by 2, that'll cancel that 2 and that 2 out, and I'm going to divide by 2 over here. So then I have x squared plus y plus 2 squared equals 18. So now this should be in vertex form or graphing form, and we should have an x center at 0 and y at -2, which matches what our image is over here. And then the radius is going to be the square root of 18. And we know that the square root of 16 is 4, so this should be a little more than 4. 1, 2, 3, 4, plus a little extra to get out here, matches our radius of root 18. Given the equation of the circle, how might you find the center and the radius of the circle? So we know that in the equation, x minus h squared plus y minus k squared equals r squared, and h comma k is the center, and r is the radius. So that's how we know. All right. If we want to graph this, we want to first identify our center, in this case, +3, 0. So we're going to go over 3, up 0. And then our radius is going to be the square root of 25, which is 5. So I'm going to go up 5, down 5, to the right 5, and to the left 5. And my circle is extending all the way to the maximum edge around here. So that is how we graph this, given the equation. Now, if we're given the circle and we want to write the equation, we're going to again identify the center, which in this case is 3, -1. And then we need to count for the radius, 1, 2, 3, 4. So the radius is 4. So our equation is going to be x minus the x value at the center, which is 3. Then we're going to square it, plus y minus -1, so it's going to look like y plus 1 squared, equals the radius squared, so 4 times 4, which is 16. All right, again, you can now do this one on the left. This one, start by dividing everything by 2 so that you have vertex form, and then go from there to graph. All right, so now they're giving you the equation and the general form equation, but we already talked about that yesterday. And you are asked to take general form and turn it into center radius form, or what we call graphing or vertex, or we don't call it vertex form, graphing form. And we do that by completing the square, not once, but twice most of the time, assuming we have x and y values for both. So again, I'm going to start just like we did yesterday by putting my x values together, x squared plus 10x. And then I'm going to add the box because I'm going to complete the square. So I'm going to determine complete the square value that I need to add there in a moment. And then I'm going to write my y's together, y squared minus 6y, and then plus this box again, equals -4, which is what I get when I subtract 4 on both sides originally. And then, of course, if I add something to one side, I have to add it to the other side. So we have 2 boxes on the left. We're going to need to add on the right as well. To complete the square, we are looking for a perfect square. In other words, something that multiplies to some value and adds to 10 and is exactly the same. So that's going to be half of 10, which is 5, and 5 times 5 is 25. So again, what multiplies to 25 and adds to 10 gives us 5 and 5. 25 goes in this box, and then, of course, over here as well. This gives us the factor x plus 5 squared, and now we're already a lot closer to getting back to that graphing form. This one, we want to know what adds to negative 6, and again is identical on both sides. So half of negative 6, which is negative 3. Negative 3 times negative 3 is positive 9, so that's again what goes in the box. In other words, what multiplies to 9 and adds to negative 6 is going to be negative 3 and negative 3, a perfect square again, which was our goal. So now we get y minus 3 squared. So our graphing form is now x plus 5 squared plus y minus 3 squared, which equals, we're going to have negative 4 and 9, which gives me 5, and 5 plus 25 is 30. So there is my graphing form. The center of this circle is going to be at negative 5, positive 3, again, h comma k, and the radius of this is going to be the square root of 30. And then you're going to ask yourself, can I simplify the square root of 30? Is there a perfect square that I can divide out of 30? And if you can simplify the radius. You're going to handle that next one. Looks pretty typical. This third one, again, looks like I might need to try and factor something out here.